The periodic table is organized into columns that we call groups and rows that we call periods. So this is period 3, for example, highlighted in green, and this is group 16. The numbers that you see in the periodic table here that we use to organize the elements are the atomic numbers. So the atomic number of hydrogen is 1, the atomic number of lithium is 3. So when you know the atomic number, you know where that element is going to be in the periodic table. And you notice how it tells us where metals are. In this case, they're highlighted with this color. Where non-metals are, highlighted with this color. Where noble gases that are also non-metals, where they are, and where the metalloids are located. Now, like in everyday life, we group things that share the same properties. Like, for example, if you are going to have a soccer game, the two groups that are going to compete are going to wear different jerseys. For example, the blue group and the green group. So they share the same property in that case, wearing the same t-shirt. Same thing here. Equivalent to the t-shirt would be the valence band, the outermost shell. Like the t-shirt would be the outermost garment of the players. The outermost garment of an atom is the outermost shell, the valence band. So elements in the same group are going to have the same number of valence electrons. For example, hydrogen, lithium, and sodium, phosphorus, all of them have 1 electron in the outermost shell. Group 2, 2 elements in the outermost shell. I'm not going to talk about groups 3 to 12 because for this level of coverage, I'm sticking to just the first 3 periods. And these are not going to come into the first 3 periods. So 1 valence electron in the valence band, 2, 3 for group 13, 4 for group 14, 5, 6, 7, and 8. 8 except for helium, since the first period has only 1 shell, and that 1 shell has a capacity of 2 electrons only. So group 18, except for helium that has 2 electrons, the rest are going to have 8 in the outermost shell. Now, because they have the same number of valence electrons, these elements are going to have the same chemical properties. So group 1 elements are going to have the same chemical properties as each other. Group 2 elements are going to have the same chemical properties. Group 13 are going to have the same chemical properties, etc. Now, hydrogen here is a slight exception, and that's again because the first period includes a shell that has only 2 electrons, that has a capacity of only 2 electrons. So hydrogen kind of sometimes has properties like group 1 elements, sometimes it's going to have properties like group 17 elements. And actually, for higher level coverage, we can talk of the properties of hydrogen and how it bonds with other elements. That's beyond the scope of this presentation. So group 1, same chemical properties. Group 2, same chemical properties. 2 valence electrons, etc. Now, periods, all what they tell us is how many shells we have. Period 1, we have only 1 shell. Period 2, we have 2 shells. Period 3, 3 shells, etc. it does not have a bearing on the chemical properties. Periods don't have bearings on the chemical properties. It sounds strange because the title is periodic table. It does not matter in chemistry. It's having more shells, that's making it bigger. That's more a physical property than a chemical property. Okay, so this is the text of what I just talked about. Okay, and here another look at a periodic table. So for example, period 1, we have only one shell. So it has a capacity of 2. So for hydrogen that has an atomic number of 1, so only one electron. So it's going to be in that valence shell. Helium that has an atomic number of 2, 2 electrons are going to be in that shell. That shell is now full. That's why it is in group 18. Period 2, lithium that has an atomic number of 3. So 3 protons and 3 electrons. The first 2 electrons are going to fill the first shell, and the remaining electron is in the second shell. So our second shell is the valence band in this case. And it has 1 electron like hydrogen. That's why both are in group 1. Sodium that has 11, an atomic number of 11. 2 in the first shell, so it is full to capacity. 8 in the second shell, it's again full to capacity, so 2 plus 8, 10. The remaining 1 is in the outermost shell, the valence band, so it has only 1. That's why all 3 here are in group 1. If we look, for example, at group 14, carbon has an atomic number of 6, 2 in the first shell, and the remaining 4 in the second shell, so 4 valence electrons. Silicon has an atomic number of 14, 2 in the first shell, the next 8 in the second shell, so 2 plus 8, 10. The remaining 4 are in the valence band, the outermost shell. So 4 valence electrons. You can do the same analysis for group 17. Here, group 18, helium has 2 electrons in the outermost shell, so it is full. Neon has 10, so 2 in the first shell and the remaining 8 in the second shell, so the valence band is again full to capacity. So that's why it is a noble gas. And the same thing for argon, 2 in the first shell, 8 in the second shell, and the third shell, the valence band, has also 8, so it's again full. So all of these group 18 have a full valence band.